Hi guys, today I'm talking about Airbus A380. In this video I will bring you all the facts about the production and total cost, takeoff and landing separation, engines, inside the cabin and used materials and design, fuel capacity, avionics, frequency and capacity of the Airbus A380 aircraft. Stay tuned from the beginning to the end of this video to know all about it. If you haven't subscribed to my channel, don't forget to subscribe now. So let's go to the video without further ado. The Airbus A380 is a wide-body aircraft manufactured by Airbus. It is the world's largest passenger airliner and world's first twin-deck airliner. Airbus launched the $10.7 billion A380 program on December 19, 2000. The first prototype was unveiled in Toulouse on January 18, 2005, with its first flight on April 27, 2005. It obtained its type certificate from the European Aviation Safety Agency, EASA, and the U.S. Federal Aviation Administration, FAA, on December 12, 2006. It was first delivered to Singapore Airlines on October 15, 2007 and entered service on October 25. On February 14, 2019, after Emirates reduced its last orders in favor of the A350 and the A330neo, Airbus announced that A380 production would end in 2021. The full-length double-deck aircraft, sometimes nicknamed the Super Jumbo, has a typical seating for 525 passengers, with a maximum certified capacity for 853 passengers. It is powered by 4-engine Alliance GP7200 or Rolls-Royce Trent 900 turbofans, providing a range of 14,800 kilometers. As of June 2021, Airbus has received 251 firm orders and delivered 248 aircraft. Emirates is the biggest A380 customer with 123 ordered, of which 120 have been delivered. In June 1994, Airbus announced its plan to develop its own very large airliner, designated as A3XX. Airbus considered several designs, including an unusual side-by-side combination of two fuselages from its A340, the largest Airbus jet at the time. On December 19, 2000, the Supervisory Board of newly restructured Airbus voted to launch a $10.7 billion project to build the A3XX, redesignated as A380, with 50 firm orders from 6 launch customers. The aircraft configuration was finalized in early 2001, and manufacturing of the first A380 wingbox components started on January 23, 2002. The development cost of the A380 had grown to 11 to 14 billion euros when the first aircraft was completed. In 2018, unit cost was $445.6 million US. Major structural sections of the A380 are built in France, Germany, Spain, and the United Kingdom. A380 components are provided by suppliers from around the world. The 4 largest contributors, by value, are Rolls-Royce, Safran, United Technologies, and General Electric. Airbus's A380 aircraft sections were transported from sites in Broughton, UK, Hamburg, Germany, Port Real, Spain, and Saint-Nazaire, France, in a specially constructed huge roll-on or roll-off vessel, the Ville de Bordeaux, built by the Jinling shipyard in Nanjing, China. The vessel was launched in July 2003, and had the largest water stern door ever built on a roll-on or roll-off vessel. In 2005, 5 A380s were built for testing and demonstration purposes. The first A380, registered FWWOW, was unveiled in Toulouse January 18, 2005. It first flew on April 27, 2005. This plane, equipped with Rolls-Royce Trent 900 engines, flew from Toulouse, Blagnac Airport with a crew of 6 headed by Chief Test Pilot Jacques Rosé. Rosé said flying the A380 had been like handling a bicycle. On December 1, 2005, the A380 achieved its maximum design speed of Mach 0.96 in a shallow dive. In 2006, the A380 flew its first high-altitude test at Addis Ababa Bole International Airport. It arrived in North America on February 6, 2006, landing in Iqaluit, Nunavut in Canada for cold weather testing. On September 4, 2006, the first full passenger carrying flight test took place. The A380 was initially offered in two models, the A380-800 and the A380F. The A380-800's original configuration carried 555 passengers in a three-class configuration, or 853 passengers in a single-class economy configuration. The second model, the A380F freighter, would have carried 150 tons of cargo over a range of 10,400 kilometers. The A380 is offered with the Rolls-Royce Trent 900 or the Engine Alliance GP 7000 turbofan engines. The Trent 900 is a combination of the 3-meter fan and scaled IP compressor of the 777-200X or 300X Trent 8104 technology demonstrator derived from the Boeing 777's Trent 800 and the Airbus A340-500 or 600's Trent 500 core. Due to its modern engines and aerodynamic improvements, Lufthansa's A380s produce half the noise of the Boeing 747-200 while carrying 160 more passengers. In 2012, the A380 received an award from the Noise Abatement Society. Rolls-Royce is supporting the CAA in understanding the relatively high A380 or Trent 900 monitored noise levels. Sufficient braking capacity allowed for thrust reversers to be installed on only the inboard engines. The outboard engines lack them, reducing the amount of debris stirred up during landing. The reversers are electrically actuated to save weight and for greater reliability than pneumatic or hydraulic equivalents. The takeoff length is 2,900 meters at maximum weight at sea level, ISA plus 15 degree conditions, and the initial cruise altitude 35,000 feet. The aircraft complies with the noise emission limits of ICAO for overfly, approach and side-on maneuvers and the stricter regulations of London Heathrow Airport concerning takeoff and landing. This enables aircraft operations at night. There are 10 fuel tanks with a capacity of 131,000 liters of fuel. Refueling can be carried out in 40 minutes. The A380's wings are sized for a maximum takeoff weight, MTOW, over 650 tons to accommodate these future versions, albeit with some internal strengthening required on the A380F freighter. The optimal wingspan for this weight is about 90 meters, but airport restrictions have limited it to less than 80 meters, thereby lowering the aspect ratio to 7.8, which reduces fuel efficiency by about 10% and increases operating costs a few percent, given that fuel costs constitute about 50% of the cost of long-haul aeroplane operation. The common wing design approach sacrifices fuel efficiency on the A380-800 passenger model because of its weight, but Airbus estimates that the aircraft's size and advanced technology will provide lower operating costs per passenger than the 747-400. The wings incorporate wingtip fences that extend above and below the wing surface, similar to those on the A310 and A320. These increase fuel efficiency and range by reducing induced drag. The wingtip fences also reduce wake turbulence, which endangers following aircraft. While most of the fuselage is made of aluminium alloys, composite materials comprise more than 20% of the A380's airframe. Carbon fiber reinforced plastic, glass fiber reinforced plastic and quartz fiber reinforced plastic are used extensively in wings, fuselage sections, such as the undercarriage and rear end of fuselage, tail surfaces, and doors. The A380 is the first commercial airliner to have a central wing box made of carbon fiber reinforced plastic. It is also the first to have a smoothly contoured wing cross-section. The wings of other commercial airliners are partitioned span-wise into sections. This flowing continuous cross-section reduces aerodynamic drag. Thermoplastics are used in the leading edges of the slats. The hybrid fiber metal laminate material glass laminate aluminium reinforced epoxy is used in the upper fuselage and on the stabilizer's leading edges. This aluminium glass fiber laminate is lighter, and has better corrosion and impact resistance than conventional aluminium alloys used in aviation. Unlike earlier composite materials, glass laminate aluminium reinforced epoxy can be repaired using conventional aluminium repair techniques. Newer weldable aluminium alloys are used in the A380's airframe. This enables the widespread use of laser beam welding manufacturing techniques, eliminating rows of rivets and resulting in a lighter, stronger structure. High-strength aluminium type 7449 reinforced with carbon fiber was used in the wing brackets. It takes 3,600 liters of paint to cover the 33,000 square feet exterior of an A380. The paint is 5 layers thick and weighs about 650 kilograms when dry. The A380-800's cabin has 5,920 square feet of usable floor space, 40% more than the next largest airliner, the Boeing 747-8. The cabin has features to reduce traveler fatigue such as a quieter interior and higher pressurization than previous generations of aircraft. The A380 is pressurized to the equivalent altitude of 5,000 feet up to 39,000 feet. It has 50% less cabin noise, 50% more cabin area and volume, larger windows, bigger overhead bins, and 60 centimeters more headroom than the 747-400. Seating options range from 3-room 130 square feet residence in first class to 11 across in economy. A 380 economy seats are up to 48 centimeters wide in a 10 abreast configuration, compared with the 10 abreast configuration on the 747-400 that typically has seats 44.5 centimeters wide. On other aircraft, economy seats range from 41.5 to 52.3 centimeters in width. The A380's upper and lower decks are connected by 2 stairways, one fore and one aft, with both being wide enough to accommodate 2 passengers side by side. This cabin arrangement allows multiple seat configurations. The maximum certified carrying capacity is 853 passengers in an all-economy class layout. Airbus lists the typical 3-class layout as accommodating 525 passengers, with 10 first, 76 business, and 439 economy class seats. Airline configurations range from Korean Air's 407 passengers to Emirates 2-class 615 seats and average around 480 to 490 seats. The Air Austral's proposed 840 passenger layout has not come to fruition. The A380's interior illumination system uses bulbless LEDs in the cabin, cockpit, and cargo decks. The LEDs in the cabin can be altered to create an ambience simulating daylight, night, or intermediate levels. On the outside of the aircraft, HID lighting is used for brighter illumination. Airbus's publicity has stressed the comfort and space of the A380 cabin, and advertised onboard relaxation areas such as bars, beauty salons, duty-free shops, and restaurants. Proposed amenities resembled those installed on earlier airliners, particularly 1970s wide-body jets, which largely gave way to regular seats for more passenger capacity. Airbus has acknowledged that some cabin proposals were unlikely to be installed, and that it was ultimately the airline's decision how to configure the interior. Initial operators typically configured their A380s for 3-class service, while adding extra features for passengers and premium cabins. Launch customer Singapore Airlines introduced partly enclosed first-class suites on its A380s in 2007, each featuring a leather seat with a separate bed. Center suites could be joined to create a double bed. A year later, Qantas debuted a new first-class seat bed and a sofa lounge at the front of the upper deck on its A380s, and in 2009 Air France unveiled an upper-deck electronic art gallery. In late 2008, Emirates introduced shower spas in first class on its A380s, allowing each first-class passenger 5 minutes of hot water, drawing on 2.5 tons of water, although only 60% of it was used. Etihad Airways and Qatar Airways also have a bar lounge and seating area on the upper deck, while Etihad has enclosed areas for 2 people each. In addition to lounge areas, some A380 operators have installed amenities consistent with other aircraft in their respective fleets, including self-serve snack bars, premium economy sections, and redesigned business class seating. The Hamburg Aircraft Interiors Expo in April 2015 saw the presentation of an 11-seat row economy cabin for the A380. Airbus is reacting to a changing economy. Airbus Chief of Cabin Marketing, Ingo Wugestzer, told Aviation Week in Space Technology that the standard 3-class cabin no longer reflected market conditions. The 11-seat row on the A380 is accompanied by similar options on other widebodies, 9 across on the Airbus A330 and 10 across on the A350. The A380 employs an integrated modular avionics (IMA) architecture, first used in advanced military aircraft, such as the Lockheed Martin F-22 Raptor, Lockheed Martin F-35 Lightning II, and Dassault Rafale. The main IMA systems on the A380 were developed by the Thales Group. Designed and developed by Airbus, Thales and Diehl Aerospace, the IMA suite was first used on the A380. The suite is a technological innovation, with network computing modules to support different applications. The data networks use avionics full duplex switched Ethernet, an implementation of a Ring 664. These are switched, full duplex, star topology, and based on 100 base TX fast Ethernet. This reduces the amount of wiring required and minimizes latency. Rockwell Collins supplies communication systems, including VHF and HF radios, and multimode receivers. Northrop Grumman provides the LTN-101E inertial navigation system. Smiths Industries provides the video management unit, which includes the display from cockpit door and cabin surveillance systems. L3 Aviation Recorders of Florida provides flight data and cockpit voice recorders. The Network Systems Server, NSS, is the heart of A380's paperless cockpit. It eliminates bulky manuals and traditional charts. The NSS has enough inbuilt robustness to eliminate onboard backup paper documents. The A380's network and server system stores data and offers electronic documentation, providing a required equipment list, navigation charts, performance calculations, and an aircraft logbook. This is accessed through the MFDs and controlled via the keyboard interface. Airbus used similar cockpit layout, procedures and handling characteristics to other Airbus aircraft, reducing crew training costs. The A380 has an improved glass cockpit, using fly-by-wire flight controls linked to side sticks. The cockpit has 8 15 by 20 cm liquid crystal displays, all physically identical and interchangeable, comprising 2 primary flight displays, 2 navigation displays, 1 engine parameter display, 1 system display and 2 multifunction displays. The MFDs were introduced on the A380 to provide an easy-to-use interface to the flight management system, replacing 3 multifunction control and display units. They include 40 keyboards and trackballs, interfacing with a graphical point-and-click display system. Power-by-wire flight control actuators have been used for the first time in civil aviation to back up primary hydraulic actuators. Also, during certain maneuvers they augment the primary actuators. They have self-contained hydraulic and electrical power supplies. Electro-hydrostatic actuators, EHA, are used in the aileron and elevator, electric and hydraulic motors to drive the slats, as well as electrical backup hydrostatic actuators, EBHA, for the rudder and some spoilers. A380's 350-bar hydraulic system is a significant difference from the typical 210-bar hydraulics used on most commercial aircraft since the 1940s. First used in military aircraft, high-pressure hydraulics reduce the weight and size of pipelines, actuators, and related components. The 350-bar pressure is generated by 8 declutchable hydraulic pumps. The hydraulic lines are typically made from titanium. The system features both fuel and air-cooled heat exchangers. Self-contained electrically powered hydraulic power packs serve as backups for the primary systems, instead of a secondary hydraulic system, saving weight and reducing maintenance. The A380 uses 4 150 kV variable frequency electrical generators, eliminating constant speed drives and improving reliability. The A380 uses aluminium power cables instead of copper for weight reduction. The electrical power system is fully computerized, and many contactors and breakers have been replaced by solid-state devices for better performance and increased reliability. The auxiliary power comprises the auxiliary power unit, APU, the electronic control box, ECB, and mounting hardware. The APU in use on the A380 is the 1,300 kW Power 980A APU. The APU primarily provides air to power the analysis ground station, AGS, on the ground and to start the engines. The AGS is a semi-automatic analysis system of flight data that helps to optimize management of maintenance and reduce costs. The APU also powers two 120 kV ampere electric generators that provide auxiliary electric power to the aircraft. There is also a ram air turbine with a 70 kV ampere generator. Airbus measured pavement loads using a 540-ton ballasted test rig, designed to replicate the landing gear of the A380. The rig was towed over a section of pavement at Airbus facilities that had been instrumented with embedded load sensors. It was determined that the pavement of most runways will not need to be reinforced despite the higher weight, as it is distributed on more wheels than in other passenger aircraft with a total of 22 wheels. That is, its ground pressure is lower. The A380 undercarriage consists of 4 main landing gear legs and 1 nose leg, with the 2 inboard landing gear legs each supporting 6 wheels. The A380 requires service vehicles with lifts capable of reaching the upper deck, as well as tractors capable of handling the A380's maximum ramp weight. When using 2 jetway bridges, the boarding time is 45 minutes, and when using an extra jetway to the upper deck it is reduced to 34 minutes. The A380 has an airport turnaround time of 90 to 110 minutes. In 2008, the A380 test aircraft were used to trial the modifications made to several airports to accommodate the type. In 2005, the ICAO recommended that provisional separation criteria for the A380 on takeoff and landing be substantially greater than for the 747 because preliminary flight test data suggested a stronger wake turbulence. These criteria were in effect while the ICAO's Wake Vortex Steering Group, with representatives from the JAA, Eurocontrol, the FAA, and Airbus, refined its 3-year study of the issue with additional flight testing. In September 2006, the working group presented its first conclusions to the ICAO. In November 2006, the ICAO issued new interim recommendations. Replacing a blanket 19 km separation for aircraft trailing an A380 during approach, the new distances were 11 km, 15 km and 19 km respectively for non-A380 heavy, medium, and light ICAO aircraft categories. These compared with the 7.4 km, 9.3 km, and 11 km spacing applicable to other heavy aircraft. Another A380 following an A380 should maintain a separation of 7.4 km. On departure behind an A380, non-A380 heavy aircraft are required to wait 2 minutes, and medium or light aircraft 3 minutes for time-based operations. The ICAO also recommends that pilots append the term super to the aircraft's call sign when initiating communication with air traffic control to distinguish the A380 from heavy aircraft. In August 2008, the ICAO issued revised approach separations of 7.4 km for super, 11 km for heavy, 13 km for medium or small, and 15 km for light. In November 2008, an incident on a parallel runway during crosswinds made the Australian authorities change procedures for those conditions. Singapore Airlines described the A380's landing speed of 130 to 135 knots. It's equals to 240 to 250 kilometers per hour. As of 2016, the list price of an A380 was $432.6 million US. Negotiated discounts made the actual prices much lower, and industry experts questioned whether the A380 project would ever pay for itself. The first aircraft was sold and leased back by Singapore Airlines in 2007 to Dr. Peters for $197 million. Air Insight estimates its hourly cost at $26,000, or around $50 per seat hour, for 520 seats, which compares to $44 per seat hour for a Boeing 777-300ER and $90 per seat hour for a Boeing 747-400 as of November 2015. As it has very large wing and tail surfaces to allow a stretch and a high empty weight per seat, its cost per seat advantage eroded, and the A350 to 1,777 to 9 will match it. 14 customers have ordered and taken delivery of the A380 as of April 2019. Total orders for the A380 stand at 251 as of November 2019. The biggest customer is Emirates, which has committed to order a total of 123 A380s as of February 14, 2019. Soon after, at the November 2013 Dubai Air Show where Emirates ordered 157 77X and Etihad Airways ordered 50 aircraft, totaling $20 billion. In February 14, 2019, Emirates decided to cancel its order for 39 planes. In March 21, 2019, All Nippon Airways received its first of 3 A380s painted with the Sea Turtle livery. Called the ANA Blue, this A380 will be used for 3 flights a week, going from Tokyo to Honolulu and back. Emirates had announced it would receive its final 3 A380s to be delivered with the last aircraft on November 2021, thus ending the A380 production. I have put more information about this Airbus A380 in the description below. You can also see it. So what can you say about this video? Share your thoughts with us in the comments section below. Also, don't forget to subscribe to my channel if you haven't already.